So, did I do a video about factorial in Clojure? So, let me just check it. I don't think so because yesterday I saw a piece of code which I had not touched for a long time, so I didn't do. Okay, and I got an error while trying out factorial, and let me tell you why it happened. And yeah. So, yeah, so this was my first factorial code in Clojure. So I don't know how efficient or whatever it is. So, yeah. So, actually, let me put this 1M over here. Uh, okay, let me put this as 1 because this is the original thing I just tried. So, yeah, I've got my Ripple running. So, let me just load this in my Ripple. So, this factorial is loaded. So, I get factorial of 4 is whatever it is. Okay, so 24. And I'm just printing some stuff over here. I'll tell you why, right? So that's the thing, right? And then factorial of 20, it grows quickly. So look, what's the factorial of 20? So look, it just grows quickly over here. So it's such a large number. And factorial of 40 and what to say and it throws an error, right? So why so? Because one is what's the type of one, right? So type of one is long. Okay, so but yeah, so that's the thing, right? And let's see what's the type of uh, 1M is. Okay, so that's big decimal. So okay, it has got this point something or something like that. So like it is a floating value or something like that, and type of 1N is big int. Okay, so maybe this occupies 64 bits, I don't know, and this occupies a lot of bits, I think, right? So that's the thing. So I haven't done research on that. Okay, so how to make this factorial work? So one is you can either put arbitrary precision, but I don't recommend this because factorial is never a floating point number or a number with decimals. So I don't recommend it. But this first got uh, okay, this first fixed the problem, right? So like now I just loaded a new factorial with this new code over here. So I can just, okay, let me make this bigger a little bit here. Fine. So now I can just try out factorial of 4, right? So it hits factorial of 4, 3, 2, 1. Okay, so and factorial of 20, right? So and then factorial of 40. So this one fixes it. Okay, so but the better way to fix it is using this one. So what is this type? This type is big int. Okay, so factorial is a integer. I don't know. There are factorial of fractions and all those stuff. So math people do think in a weird way, right? So like, but I'm not sure. So okay. So now if I just put factorial of 4, it's just n over here. So let me just okay, yeah, it's just n over here, and then and 20 it's like this, and 40 it's like this. Okay, so everything precedes sorry, like is being uh, prepended with this n. Okay, this n is just for the display. Okay, like maybe if you just put like, okay, like I think if you put like, okay, like println factorial of 50 or something like that. I don't think you will get n over here. Oh, you are getting n over here. Okay, so that's I never expected, right? Okay, so if we do print it to a user with this n out, I don't think that's a good stuff. Okay, but yeah, that's how Clojure is behaving right now. Okay, so or let me just put like str of um, factorial of 5. Okay, so um, okay, so 120. Okay, yeah, this is okay. Yeah, so now this is good. Okay, so this is not printing like, okay, like 120 in or something like that. So this is how you just convert this big int into a string and then you just print it. Or give it big decimal into a string and you just print it. Okay. So now let's see how this factorial works. Okay. So like, okay, let me just comment this out. Okay. So, oh yeah, let me just have it because it's a good debugging stuff, right? So first I just get number. If the number is 1, I just return 1. Okay. So if the number is not 1, I just return that number and then that factorial of number minus 1. So what really happens over here is, okay, like let's say like I'm just giving 3. Okay, so and what really happens is, okay, like this gets decomposed into 3 into factorial of 2, right? And this further gets decomposed into 3 into factorial. Okay, this is 2 into, because this is number. Okay, so and then into factorial of 1. Okay, so this is how, and factorial of 1 is 1, right? So becomes 3 into 2 into 1, and okay, so finally factorial of 1 returns 1, and this gets multiplied with 2 in the next layer, and what to say, like it becomes 2, and finally this gets multiplied with 3 and becomes 6. So that's how it happens. So if you have 1, just return 1, and for any other thing you just return that number and factorial of this thing. So in fact, like what really happens is, like, yeah, like let me just comment this out. In fact, what really happens is it's something like, okay, like factorial of 3 and then multiplied with factorial of 2 and then multiplied with factorial of 1. So that's how it happens. And finally, yeah, the factorial of 1 is 1. So and factorial of 2 is what? 2 star factorial of 1, which is 1. Okay, so this returns 2. So and finally this factorial of 3 is what to say, like mm, yeah, 2 into this factorial of 3, because 3 into factorial of 2 is what? 2. So this finally becomes 6, right? So that's how it is. Hopefully I think I explained it okay-ish. Okay, so that's the thing. So this is it. But uh, one thing about it is, like, okay, look, it needs to call a lot. Okay, like okay, like let me just put it over here, uh, like um I have this X caliber. Okay, so let's say, like, okay, like factorial of 4 is there, right? And oh, okay, right, factorial of 4, right? And uh, this calls, okay, like what to say, this calls 4 into factorial of 3. Okay, so okay, yeah, I just want to say, like, okay, a lot of calling takes place. Okay, factorial of 3, right? So and so there is lot of steps, okay, involved. So and this calls factorial of 2, 3 into factorial of 2, and so on and so forth. Won't it be good if things can be remembered? Okay, so that's the thing I was just thinking. So there is a thing called memoize. Okay, so and you just give this factorial function to this memoize, and I'm just assigning it to a variable called factem, which means for me it's factorial memoize. So this is not a good function naming. So what I'm just doing is I'm just putting okay, like let me just load it into memory. Okay, so and then now I just call factorial of 4. So it just puts 24 in, and it has been called like 4 times. Okay, factorial of 4, 3, 2, and 1, right? Okay, so and now once again I call it. So the program has memorized what has happened when we call factorial of 4. So that's why all these things are not being printed. So it's not at all getting called. Okay, it just takes it from the memory and it just gives. So think about something like you are writing a web app where thousands of people are just giving the same request. Okay, so when a Clojure function needs to handle with it, you can better memorize it. Okay, so and so that like the JSON or whatever data just gets returned rather than going deep down to database level and all this stuff, right? And similarly, like, yeah, like okay, let me just put factorial of 50. So a lot of things get hit. Okay, so but Now you might think that, okay, like since I've put factorial of 50, if I put factorial of 49, right, so it would have memorized, right? So because it has hit factorial of 49 somewhere over here, so it would have memorized, so it would just give the answer. But no. If you once again give factorial of 50, if you give factorial memorized of 50, right, so it memorizes. It just gives the answer. Look, you're not getting all this factorial of this stuff, all these printed stuff. So whenever the function is being called. And once again, if you call like this factorial of 49, so factem 49, what to say, like it just gets called from the memory. But the thing is, if you even change one bit of a number, uh, and you might think like in the stack it is getting called like this one, like factorial of 4 gets is nothing but 4 into factorial of 3, so this should also be memorized. And similarly, and this is nothing but 3 into factorial of 2, and this should also be memorized, so factorial of 2 should be memorized. So all these things would be called, but not, that's not the case. Okay, so if you give something new, it once again recomputes. So it's only memorizes the topmost level and not all the levels that goes down. So okay, so that's the thing. So but yeah, computing factorial of huge numbers is a expensive process. Similarly, like there are a lot of expensive process while you're solving real world problems. So please do memorize. So that's my advice. Okay, so that's the thing. So yeah, this is the formula it just follows. If the number is 1, it just returns 1. Otherwise, it returns number into factorial of that number minus 1. So as simple as that. And so yeah. So that's about it. And apart from that, yeah, this is how my factorial code works. And let me just check something like, let me just check whether it works with recur. So like you are supposed to use recur whenever possible. So, and the fact recur, RECUR, and then what I'll just do is I'll just put recur over here. So, RECUR. This is supposed to reduce memory or whatever that computational stuff, right? So, okay, so I just load it into memory and okay, so it doesn't work, right? So it just doesn't work. I just thought this should work and it's not working. Okay. Anyway, thanks for watching and let me just put a comment over here. So this doesn't work. Okay, so yeah. So anyway, thanks for watching. I'll make this code available on the internet and so this is how factorial was done, and just by putting 1 it didn't work for me, and then I just changed to 1m and 1n, and things started to work for me. And of course factorial is only for integers, so just use n, that is big int, not arbitrary precision double, that's waste of resources. Okay, so that's the thing. And do memorize stuff when possible, so that like if you know that a function is going to be called a lot of times, do memorize it, so that like your computational resources are saved. So that's it, what you should take from this video. So anyway, happy closuring, and until we meet in next video, bye.